Hello, this is Bob Till. In this lecture, we will take a look at a problem that will be similar to an assignment and or homework. The problem looks like this. We're going to work it in Excel, which will look like this. I suggest putting it into Excel before you put it into Connect. If you are to put it into Connect, for multiple reasons. One, it'll help with the calculations. Two, it'll help to see relationships between formulas in different cells. And three, it's just a good idea to work with Excel. And four, if you have to work the problem again, which you can do in Excel, and Connect for most of these problems, it will be a lot easier if you have it in Excel first. So let's take a look at what we have here. We got business solution sales upscaled model desk units and office chairs in a ratio of 3:2 desk to chairs. So that means we're going to have 3 desks for every 2 chairs for all the sets that we make. So these are going to be sets 3 and 2 for the sets. So the selling price is $1,250 per desk, and remember that there are 3 desks in a set desk unit, and $500 per chair, and there's 2 chairs per desk unit. So the variable costs are $250 per desk unit and $250 per chair. Fixed costs are $120,000. So first, I want to put that ratio in here, that 3:2, and show you what happens in a cell reference if we put 3:2 into here and we hit enter. Notice what Excel does. It tries to change it into a number because we're in a number format here. Now, if we want to tell Excel, hey, just type in exactly what I'm putting in there, even though I'm putting in a number, then we could delete it and put an apostrophe first. That's what tells Excel, hey, just type what I'm typing in here, 3:2, and then it'll keep that reference there. So we'll keep that in mind as we work through the problem. So first, we're going to calculate the selling price per composite unit, meaning the units as a whole being the 3:2 up here compared. So we're going to have, and the desk selling price, they're going to give us in the text up here is this 1,250, and the chair selling price is 500. So if we were to total that up, the selling price is 1,750. And then we're going to take the units. So remember, we have this, that's where this 3 and the 2 come into place in our set. So 3 and 2 units sold. And then we're going to multiply that out to make our selling price per unit would be equal to the selling price times the number of units, tab, equal to the selling price of the chairs times the number of units, tab. And then if we sum these up this way, we have the 4,700 total cost for the composite unit. Then we're going to take a look at the variable cost per composite unit. So we're looking at just the variable portion of the cost for the composite unit, and we're breaking these out, remember, by the characteristics of the costs. So we're going to take the variable cost per unit and the desk versus the chairs. So we have 750 variable cost for the desk given to us up here, and for the chairs we have 250 given to us right there. If we sum those up, we have total variable costs per item of 1,000. And then we have the units sold, and we have in a composite unit, the same ratio, 3 and 2 desk to chairs. And if we multiply that out, we get the variable cost per composite unit. And we're going to multiply that out. That is the 750 times the 3, and that is the 250 times the 2. And if we add those up, we get our total variable cost of the 2,250 and the 500, giving us the 2,750. Then we're going to calculate our break-even point in composite units. So we're going to calculate the break-even point. So first off, I'm going to put the break-even point formula down here. So I'm going to put the break-even point formula, which is the fixed cost, over, and in order to do this in one cell, I'm going to hold down the Alt key and select Enter, and that will bring me to the second cell. So once again, Alt, Enter will bring me to the second cell, and then we're going to take it over the contribution margin per composite unit. So, and then I'm going to highlight the top of this, I'm going to go to the Home tab and I'm going to underline that. Then when we hit enter, we can see this kind of fraction format within Excel. So what we're thinking about is fixed costs. How many composite units as of this 3:2 ratio, do we need in order to cover basically the fixed cost? In order to calculate this, we could first come up with the contribution margin per composite unit. So that's why this is up here. How do we calculate that? We say it's the selling price per composite unit minus the variable costs per composite unit. So that's going to be the idea, and we just got these numbers up here. So the selling price now for the entire unit, the 3 desks and the 2 chairs within a composite unit, is 4750 minus the variable cost, the cost that change in relation to the number of units sold in a constant way, is the 2750. So that means that we're basically coming away with 2,000 per unit after variable costs. Now we can think about how many things we need to sell, how many composite units we need to sell in order to clear, in order to break even, meaning in order to cover our fixed costs being such as the rent or something of that nature. So if we look at this, if we plug these numbers into our formula, I'm going to first plug them in like this. 120,000 is the fixed cost given to us from the problem here. And then I'm going to say Alt-Enter and divide that by the 2,000. I'm going to highlight the top. This is us plugging this information into our ratio. Now, if we actually do that calculation, it would be equal to 120,000 divided by 2,000 will give us 60 per unit, per composite unit, let's say. All right, so then we're going to go to number 4, which says number of units of each product that would be sold at the break-even point. So now we're going to see how many units are going to be sold. Remember, these are composite units, and we're selling, every composite unit consists of 3 desks and 2 chairs in this case. So if we were going to do this calculation, we're going to have the break-even point in composite units, and that is 60 for both desks and chairs. And then we're going to say that the number of desk and chair per composite unit is 3 to 2. Every composite unit has 3 desks and 2 chairs. Therefore, the number of units of each product is going to equal the 60 times 3 and the 60 times 2. So these were the number of units that we're going to sell in order to get to the 60 composite units, which consist of the 3 desks and 2 chairs.